Hey guys, Mr. Riss here to help you with the second day of the 2.3 notes. So today what we're going to do is look at the quotient rule. So the quotient rule is like the product rule. It's how we take the derivative of two functions, but in this time they're going to be divided of each other. The only key is that g of x cannot equal 0. If it equals 0, it's not even a function at all. It just doesn't exist. It doesn't work out. And so we just want to make sure that we have two functions set up. So the derivative of f of x divided by g of x is g of x times f prime of x minus f of x times g prime of x all over g of x squared. Another way to remember that one, and it's a whole lot better if you hear Mr. Kryl say it, because he just has the twang that I don't have. But it is, if you think about f of x is the high function and g of x is the low function, we would say the derivative is low d high minus high d low all over low low. All right, so say it again with me. Low d high minus high d low over low low. Or if you think about it, we have the low function times the derivative of the high function minus high function times the derivative of the low over the low function squared, or low low times itself. So low d high minus high d low over low low. All righty, so let's use that to help us figure out some of these derivatives here. Okay. So if we got 5x minus 2 over x squared plus 1, if we want to find the derivative of this, we take the low function, x squared plus 1, times the derivative of the high function, which is just 5, minus the high function, 5x minus 2, over the derivative of the low, which is just 2x. And we're going to put this all over low low. So the key is just to take the low expression and square it and leave it like that. There's going to be rarely ever time that we need to distribute this out. Okay, so let's distribute the top, see what we got. So we have 5x squared plus 5. And then over here we got to distribute the negative and the 2x. So minus 10x squared and then plus 4x all over low low. Okay, so what do we get here when we combine like terms on the top? We would have a negative 5x squared, and we'd have a positive 4x and a positive 5 all over the low low x squared plus 1 squared. And that's it. It's very, very rare that we would have something factor out the top here that would factor out the bottom. If it couldn't do it at the beginning, it's just not going to do it in the derivative. Okay. And so, yeah, that's the answer. So these answers are going to look a little weird. We just got to trust yourself that we did the right work. All right, next, what if we have 4 divided by x squared minus 9? Okay, so let's go through this one, see what happens. If we have our low, which is our x squared minus 9, d high, the derivative of 4 is 0. That's going to be kind of nice. Then minus high is 4 times the derivative of the low. It's just 2x. Over low low, x squared minus 9 squared. And just keep it like that. Just keep it as the bottom part in parentheses squared. All right, what happens here if we distribute the 0? That all goes away. So we're just left with the negative 4 times 2x, which is negative 8x over x squared minus 9 squared. And so that's it. That's the derivative of the bottom. Okay, so we're going to keep practicing, kind of see everything that we could happen, or everything that could happen here. And, well, you know, we could have trig functions. Like with the product rule, we had trig functions. We can have it with the quotient rule. So the derivative, if I have low, is sine of x. D high, the derivative of 2x cubed would be 6x squared. Then minus, we would have 2x cubed. There's high, and then d low, it's cosine of x. Then all over low low, well, we can be a little fancy here. We can say that's the sine squared of x. All right, what does this simplify down to? Well, sine of x times 6x squared is just 6x squared sine of x. And then minus 2, all we can really say is minus 2x cubed cosine of x over sine squared x. And that's pretty much all we can do. Yeah, we could factor out a 2x squared from the top. but we can't factor out a sine, we can't factor out a cosine. Sine squared is just sine squared, and that's kind of it. Alrighty, let's look at the bottom here, do this next one. Make sure we're okay with the quotient rule. All right, so we got low, which is e to the x, times d high will be 4x cubed minus 3. Then we have minus high, which is x to the fourth minus 3x. And then d low, the derivative of the low is e to the x. And then all over e to the x squared. Now, this is the one few time where we could factor out an e to the x from the top. So if we take away this e to the x and take away this e to the x, and that would cancel out one of them from the bottom, we are left with a 4x cubed minus 3 minus x to the fourth plus 3x. And realistically, that's about all we can do there. We can't combine anything on the top. All we have there, and so that's it. So the e to the x sometimes puts a little wrinkle into what normally would happen. All right, so now that we know how to take the derivative using the quotient rule, we can apply that derivative. All right, so let's look at this one here. What's cosine of x divided by x? So let's figure out what that expression is first. So we got low, which is x, d high is negative sine of x. Then minus high is cosine of x. D low is just, oh, I forgot the x there. D low is just 1 all over x squared. All right, so if we wanted to simplify this, this would be a negative x sine of x minus cosine of x all over x squared. So there is the expression right now. So if we want to find the value at pi over 6, what we need to do is to plug in pi over 6 wherever we see an x. So this would be a negative pi over 6 times whatever the sine of pi over 6 is, minus whatever the cosine of pi over 6 is, all over pi over 6 squared. All right, so let's see how fancy we can get. We get negative pi over 6 times the sine of pi over 6. I gotta look up in the circle. That would be 1/2. Minus the cosine would be radical 3 over 2. This is all over pi squared over 36. Okay, I'm gonna run out a little bit of room here, but I could move some stuff around. All right, so we get a negative pi over 12 minus radical 3 over 2. And then this is still being all divided by pi squared over 36. All right, if you guys leave like that, that's fine. But let's see if we can kind of make this a little fancier. Let's multiply this by 6 over 6 to get common denominator here. And so this would be a negative pi minus 6 radical 3 over 12. And then if we were going to divide this all by pi squared over 36, that'd be the same thing as multiplying by 36 over pi squared. So what that means we need to do, one second. Sorry about that, my 3D printer was going crazy here. So if we got this, what we can do is we can divide that out and we get a 1 over 3. And so we'd get a big brain answer, a negative 3 pi minus 18 radical 3 over pi squared. Now this answer is the exact same thing as this answer here, decimal wise, and so either one's fine with me. Alrighty, let's make sure that this is all we need to do. Okay, so that wraps up the quotient rule. This is day 2. So I will see you guys next time to kind of combine these two together and take this a step further. All right, guys, have a great day. I will see you next time. Adios.